Sorry, one second. I'm just looking at the joining members, so people are still joining in. So do you mind we just take like 3 to 4 minutes? So some of the people would just...
Yeah. You want to join in too? No?
I will be watching.
Okay. So should I share the screen?
Yes, you can start up slowly. So let me just give some introductory note to all the members. Good afternoon, everyone. All the members who are currently joining in. We are very pleased to host you all here in our next episode of on-demand series of topics. And today we have our honored guest, Mr. Sioku Yoon. Sorry if I mispronounced.
No problem.
Let's try. Yeah, so if I just say Mr. Yoon, and who will be talking about and discussing the topic of technology of blockchain and everything related to digital identification and digital currency and cryptocurrencies. So this is pretty interesting and lately trending, one of the top trending topics in the recent years, and I'm sure that we are going to have a very informative session. And so thank you so much, Mr. Yoon, for taking time to devote your time and share your expertise with our delegates. We are very grateful for that. And and I think I would love to introduce yourself, but I think if you just, in few words, start off by introducing yourself, and then we can move on to the to the session.
Okay. Good afternoon. It's wonderful to be here and then talk about blockchain and digital identity and digital money. This is a really exciting technology that we are facing. So today, I'm going to talk about digital identity and digital money and its underlying technology, and also what will be the future scenario related to these technologies. So before we start, I'll briefly introduce myself. I studied computer science in University of Southern California. Actually, my graduate advisor, Professor Newman, is one of the first early pioneers in digital cash technologies. He invented a protocol called net cash. As you can see in the name, net cash means internet cash. It's one of the early stage digital cash protocol. And after that, I worked at Samsung Group as a strategic technology department, and I introduced various advanced technology like digital currency at the time, and electronic commerce, and smartphones, and etc. etc. After that, I founded the company, and I worked as a security expert in Korea, and I provide many of the key security technology to the government, financial area and major companies like Samsung, SK, and some companies in Japan like Yahoo Japan or Rakuten Group. And after that, I founded this company called Sovereign Wallet Network. Currently, I'm CEO and chief scientist of this company. Our aim is that decentralized credit banking is one of the aim that we are talking about. I'm going to briefly discuss what it is in the presentation. And I own about more than 30 patents related to software security and blockchain technologies. So to talk about the technology, let's imagine this digital utopian society. What would be? So people living in a smart city and government services all fully digitalized. And we build a company in a decentralized autonomous form so that everybody can easily build the services and companies and do the investment. So in this digital utopian society, what kind of technologies inside that kind of vision? So in the smart city, we like to digitalize 3 components, among other things. One is communication. So we're talking about 5G technologies, and especially in the 5G, I would like to focus on small cell technologies. And so we like to digitalize communication, energy, and transportation among there are many other aspects of it, but let's briefly mention some of the representative technology. And in the energy, we have a technology called smart grid. And in the transportation, many people talking about autonomous vehicle and Internet of Things. So this is the key infrastructure technology that everybody's life and many things are depending on. So in building this digital infrastructure, why we want to do decentralization? The key point of this decentralization is that we don't want to have single point of failure. If there is some terrorist attack or any kind of natural disease, disasters, and many things, on a certain day, if this digital infrastructure suddenly stops, there's a very disastrous effect. So we like to avoid this single point of failure. To build this technology, there is one of the key technologies are a blockchain technology that we're going to talk about today, and other things like tokenization and digital money also involved. By the way, if you have any question, I'm happy to answer anytime during the presentation. And let's also briefly talk about e-government. One of the hot issue nowadays is that one of the cutting edge e-government service will be the digitalization of money. So many people talking about central bank digital currency nowadays. So money will be fully digitalized, and many people hope for paperless service. Everything, every e-government service is fully digitalized, automatized, and we can do everything on a mobile phone, on the internet. So we'd like to have a digital certificate, digital notarization, and we don't want to involve any kind of paper-based services. Especially nowadays because of the COVID-19 pandemic, we like to have a contact tracing and immunity passport kind of service in the e-government. to implement this kind of technology, we need a on-contact, paperless service. So what that means in the technology point of view is a digital identity and digital money related technologies. So when you talk about decentralized autonomous company, so when we are talking about first industrial revolution, previous industrial revolution technologies mostly related to production or the factory, how to improve the efficiency of the production. But in the fourth industrial revolution, nowadays, the company itself, how we do the business and the form of the company itself can be changed. So instead of having a physical company, we can have a virtual digital company, and we can invest. We can receive investment from the worldwide as a tokenization technology, and we can have a digital voting. Instead of holding the shareholder meeting in the meeting room with a physical contact, we can have some governance protocol that automate those kind of shareholder meetings and election of the CEOs and executives. And also smart factory, of course. But in here, we want to have some kind of tokenized payment. So, and blockchain. So many of the logistics and payment and purchasing of things and robots, everything will be automated. So in here, we are talking about some tokenization and voting. To implement this, we also need a digital identity and digital money related technologies. So we have this vision, but what this driving this change and the evolution is that technological evolution in the internet itself. So everybody knows that at the beginning, we invented internet protocol. Then we'll be able to transfer the data over the internet in a peer-to-peer way. So with the invention of this internet technology, we'll be able to develop many websites and commerce services on there. But there is one problem. Other data service, we can build a website and then service the data over the internet in a peer-to-peer way, but receiving payment is the problem. We cannot transfer the money over the internet. But after invention of this blockchain and cryptocurrency and digital currency technology, now it is possible to transfer the value. That is money or some kind of value, not just some money. We can transfer some kind of ownership or other digital rights over the internet. The key technological problem in the internet is before, in the first generation of internet, it was the data. So data can be copied in a digital world. But if the data is the money, if you copy the money, send it over, it's a double spending. So we have to prevent this kind of technology. So at the beginning, it was just the data. Now it's the data that has a value. So you have to prevent some kind of copy and fraud. So with the blockchain and digital currency technology, now we are solving the second generation problems. But still there is one more problem. From the beginning, internet is designed as anonymous technology. So we don't know who if you build a website, we don't know who is accessing to. We are doing this seminar, but because everything is the internet, we don't really know who is watching this seminar or accessing to. So there is another problem that needs to be solved. That is identity. We have some current technology has a little bit of problems and drawbacks. So we'd like to moving into the next generation of identification technology. So that's a big picture underlying the evolution of this internet. So let's first talk about the blockchain. In the blockchain means is a combination of two words, block and the chain. So inside the block, what's inside the block? Inside the block, there is a transaction data. Transaction data is actually the trade data. So if I send the money to someone, sending money to A address to B address, those are the transactions. So inside the block, there is a transaction data are involved, and those blocks are chained together to have an immutable data structure. So what immutable is that this is append only and cannot be changed. So in digital transfer of the value, digital transfer of the money, since digital transfer can be copied, if I send the money to A person and then copy the same data and send the money to B person. So we have to avoid this. To avoid this, if I sending something and that transaction is inside the blockchain, they cannot be reversed, cannot be changed in the later. So those are the blockchain technology. The blockchain is distributed, immutable, and event sourcing. Distributed meaning instead of having single source of truth, instead of having big, large company having all the data inside the organization and do the transaction and management, instead of having one single entity having all the data, we distributed the data to everyone involved in the transaction. So data is copied and distributed all the entity in the network, and that's the meaning of distributed. And second definition is immutable, means blockchain is read-only, append-only data, so that it cannot be reversed or changed. And event sourcing is another meaning is that all the transaction data is recorded inside. So what that means is that in the bank account, I can store my current balance only, or I can store all the history of my spending and earnings. So in the blockchain, instead of just storing the end result, we have all the historical data involved. So if you have in the Bitcoin, for example, if you have one Bitcoin balance, that balance can be just created one, or could be block reward or anything. So all the trace from the Genesis block to my Bitcoin, all the information is recorded inside the blockchain. It's event sourcing. The blockchain is related to how we can store the data. And since the blockchain, every data is distributed, stored in the multiple entity. So how can you make sure this data is correct? How can we agree on certain data, whether this data is correct or not? That's called consensus protocol. And one of the representative consensus protocol is the Nakamoto consensus. Many people think that consensus protocol is a proof of work, but proof of work is just one set of the big story. Many people heard about proof of work, and proof of work is some cryptographic puzzle that we need to solve to mine the Bitcoin or other tokens. But instead of going into detail, fundamental meaning of proof of work is a randomization protocol. So what that means is that there is a new transaction data who have the right to write a new block. how we're gonna select or choose the random person random node who can write the data in the next block. So proof of work is one way to randomize the block validators. But actual protocol involved in another rule called the longest chain rule. So if there is two different blocks, so A people goes in this way, and then the B people goes in the another way. And if there is a fork, there is some difference in the data, and which one we will choose to be the right blockchain. That's called the longest chain rule. So in the Bitcoin protocol, we just choose the longer chain because that requires more effort to build a blockchain. So we always have to choose the longer chains. The combination of longest chain rule plus proof of work are the Nakamoto consensus. And one more thing is that even though we have a block is written, because there is always possibility that if there is some other longer chain, my block can be rejected, opponized. That means my transaction will be invalid in the future. So even though my transaction is written inside, included inside the block, we not have 100% certainty that my transaction is confirmed. Transaction will stay there in the blockchain forever. So this is called a probabilistic confirmation. So this is the reason why we are waiting about on 6 block to be in recorded from my transaction. After my transaction, we waiting about 6 block to be confirmed, to be generated, attach it from my block, and that takes about 1 hour in the Bitcoin. So in the Bitcoin and many of the proof of work protocol, this is a probabilistic confirmation. We have if we have a long chain behind my transaction, we have a more probability that my transaction will stay there forever. So even though we have this blockchain technology and longest chain rule consensus protocol, but the problem is that we not have still 100% sure that this Bitcoin and other blockchain system will work. So in the Bitcoin, there is one more mechanism is involved in. The one is called token incentives. So let's assume that if there is a new person want to join because Bitcoin and many of the public blockchain, any entity can join freely. This person can choose to attack the system or contribute to the system. To prevent any kind of unknown people when newly join the node to act maliciously to attack the system, we have an incentive mechanism. So that if they behave maliciously, behave badly, they lose value. So any kind of selfish node, if they act as a self-interest, it's better to contribute to the network and get the reward because that's the beneficial. So we have this kind of token economics because blockchain technology and consensus technology and digital technology, computer software technology itself cannot guarantee the 100% security. We have some kind of incentive, economic model to make it more secure. That's a token incentive. And in the Bitcoin, not only that kind of incentive mechanism, they also have some kind of other economic model called some other token economy model. So they have a market cap. There is a limit in the total number of tokens that can be generated in the Bitcoin. It's about 21 million tokens. And incentive goes down in every, around every 4 years, in every 210,000 blocks. That means token generation can be reduced to avoid inflation and degrading of token values. So in the blockchain and Bitcoin and cryptocurrencies, there's not only just the software technologies, there are also many economic understandings and economic concept is involved in. So when people talking about blockchain technology, in broadly, they talking about these three things combined. Blockchain, how to store the data in an immutable way, and consensus protocol, how to agree on this data, and other tokenization and token incentive model. But these are the little bit three different technologies we need to consider in designing a new blockchain system. In designing a new blockchain system, there are very popular concept of impossibility trilemma. So when anyone design a system, is the leader of Ethereum blockchain, Vitalik Buterin, talk about this trilemma, and he said that three desirable features in the blockchain: decentralization and scalability and security cannot be achieved at the same time. So two features, two targets can be achieved easily, but we cannot achieve three things at the same time. This impossibility trilemma. So, for example, what's happening in, because people prefer decentralization, and what's happening, and because of in the Bitcoin, it emphasizes decentralization and it sacrifices the performance, scalability. In the confirmation, Bitcoin takes about 10 minutes to create a new block. So it's about 1 hour to confirm any kind of transaction. So they sacrifice the scalability. And then many of the later blockchain project, they say that we are much faster. So what's end up doing is sacrifice the security, so, or decentralization. So instead of everyone in the blockchain agree on the certain, doing the consensus protocol, if you select a few people, like some leaders, and they can be, if the only 21 nodes or only few nodes agree on the things, so we sacrifice the decentralization, but it increases scalability. But also it can, if there is only 21 nodes that is acting on the validation of node, we can attack those 21 nodes. So we can have a persistent targeted attack, so reduce the security. So this is a interrelated concept or interrelated feature. So we can, in designing a blockchain, we have to balance. Someone can come up with a perfect equilibrium. There's in the single point in the triangle, but currently is wide adoption, wide understanding of these technologies that is not really possible to achieve these three goals at the same time. And not only in the blockchain has a trilemma, there are many trilemmas in other areas. So since we are talking about digital money, we have to think about the trilemma in the tokenization protocol. So in the economics, there is a trilemma. So economic trilemma is we can achieve three things: sovereign monetary policy and stable exchange rate and free capital flow. So free capital flow meaning that whether we can allow any people to exchange local currency to dollar and then go out of country freely or not. Or we can limit the kind of action, or we can have a fixed exchange rate against the dollar, or we can have a variable exchange rates, or we can publish money at will or not. So these three things are interrelated concept. If you publish too much money, it will create the inflation, and then exchange rate will be go down, and people want to have better money, so people want to choose alternative currencies. So this is an economic model, but in the economic model, it's a little bit difficult to think about in terms of tokenization. So I changed this economic model into another term. So in the circle, parenthesis, I talk about my term is a collateralized asset. So in the tokenization, whether we have, when we generate the token, whether we have a backup asset. So in the stable currency, like USDT, they have a equal number of US dollar in the bank account and generate the token. So whether we have this kind of collateralized asset or not, this is one question. And so if you have a 100% collateralization and 100% liquidation, we can have a very stable token. But if you do not have 100% based on demand and relying on algorithmic central bank model, then the price can be fluctuated. So maybe Bitcoin and other cryptocurrency price can fluctuate based on this model, whether we can have a stable price or not. And also velocity, whether people prefer Bitcoin or Ethereum or fiat currency, or what will be the preference model. So even though how much we generate token, if there is a problem in the liquidity, or people don't prefer using this token. So these three goals are interrelated, and in the token economy, it's very difficult to achieve all these three things, all these desirable characteristics at the same time. So we have to carefully design how to do it. And there are many other things to consider in designing a blockchain, but just like said in the slide, it's too long, don't read. And I cannot talk about everything today, but I just want to briefly mention. And in private blockchain, like permission blockchain, like Hyperledger, there is orderer. So in the blockchain, the transaction can be generated randomly. So how we can decide whether this transaction generated first or second? How can you serialize these transactions? In this, a little bit of private blockchain, a little bit of centralized system is a little bit easier. So if there is orderer, single orderer in the network can receive all the transaction and then decide which one comes first. And we can also have a timestamp model. But in the timestamp model, there's a problem of global clock. The node that generate the transaction put the timestamp, but how can you make sure that the time is exact, time is correct? And also another problem is the governance model. We all heard about there is a hard fork in the Ethereum and the Bitcoin. The Bitcoin is separate from Bitcoin to Bitcoin Cash. And this is a problem of governance protocol. Once we develop the project, Then once we develop the blockchain system, once it's deployed, it's very difficult to change the code, change the protocol. How can you find a way to smoothly find a way to upgrade the protocol? So first one come up with the idea was the Tejos. Tejos come up with the idea called self-amending ledger, and people involved in the blockchain protocol, they can agree. There is a protocol to agree on the improvement or change in the protocol. So that's the governance protocol. Any of the modern blockchain should have this governance protocol. Otherwise, in some time later, only way to improve the protocol will be hard fork. That's not a good sign to do it. And also we need to think about privacy of the transaction. In the Bitcoin and current, many of the cryptocurrency technologies that all the transaction data are open to everyone involved in the network. So some of the people don't like to be traced and things like they're working on building on some randomization or obfuscation of make it hidden of these transactions. There are many technologies. One of the early technology was a blind signature by DigiCash. And nowadays Monero have a link signature and Gcash have a zero knowledge encryption technology. But this is not desirable maybe in the cryptocurrency, but it is quite desirable in many of the enterprise blockchain, especially digital money protocol. Since current banking system, we need to protect some of the privacy or transaction data of users. So in the designing of digital money, we need to think about whether we to adopt this technology or not. Also the data privacy. In the identity system, if the identity information is in the blockchain, then everybody can see and use. It's the real big problem. So how can you achieve the data privacy? There's technology called zero knowledge proof and homomorphic encryption and other technology. And we have to think about address and authorization. In the current cryptocurrency, we use the public key cryptography to generate the address and then some authorization key. But the problem is that everything is anonymous. Whether we to allow this kind of system or whether we to have a same kind of system in the digital money, especially central bank digital currency. So we have to think about the identity and then basic address mechanisms, and also some programmable money problems, smart contract and chain code. There are, either you come up with a smart contract and then widely adapt it, but there is one of the major problems is the scalability issue. Everybody heard about CryptoKitty. We create a certain kind of DAR or cat, virtual cat inside the system using the programming. But just a few digital cat in the system, whole system is almost full. So there's a big scalability issue. So when you have this digital central bank digital currency, and then we like to provide some kind of programmable money, how can we make it scalable? How can you make this programmable money feature can be used widely, nationwide, or maybe billions of people can use it? These are the questions and topics we need to think about in designing the blockchain system. So next up is the digital identity. Current digital identity is basically federated identity model. So centralized is easy. If you have a website controls and manages all the identity. You just register, provide all your identification information, and then log in with the ID and password. That's a centralized model. Nowadays, with the OpenID and OAuth technology, we can have a federated identity model. And you can think about Facebook login, Google login, GitHub login, LinkedIn login, those kind of technologies, federated identity model. In both centralized and federated identity model, person is kind of out of circle. Person cannot control their own identity information. All the identity and data is managed by the either issuer in the central issuer and the verifier. So person cannot have any kind of control over its own identity. And to solve this problem, nowadays people are talking about self-sovereign identity. So in the self-sovereign identity model, person, the identity owner, is the one who controls the identity information. So of course we are using the blockchain network. And I'll talk about more detail in the next slide. And building blocks of self-sovereign identities are these 5 things. We have a wallet. So wallet belongs to the person, identity owner, and then wallet can contain many identification information called verifiable credentials. So verifiable credentials is identity information certified by certain authority, like if I have a national ID number, that ID number, those kind of identification information should certify, checked, confirmed by the government. So in that case, government becomes the issuer, and those kind of information, verified credential, will be stored in the wallet. And I can present my national ID to in the airport or in another country. And all this information and communication can be managed, and trust will be established by the blockchain. So this is a basic model of self-sovereign identity. My identification information is issued by the government, maybe national identification number, and in the form of verifiable credentials, issued credentials is called claims here, but actually this is some people say verifiable claims, or some people say verifiable credential, but the term it can be used by vice versa. So anyway, those issued claims can be stored in the wallet. And if you go to the, if you want to work for the company, and you can present your information, the claims to the company, and the company can verify those information on the blockchain. So one of the reasons why we are doing all these things is how can we change the model that I can have a control, and also there are many verification informations. So one thing we'd like to solve is that instead of presenting all information, if you use the passport, you can, all you need to do is just prove that you are 21 years old. But to do that, you have to give the full information. So if you can separate these credentials and control by identity owner, it could be much more beneficial model. So on the wallet, there are these separate credentials will be stored and signed by the authority. So there are a lot of public keys and private keys are involved. So simply, DID means certain information signed by some trust authority, or it could be a peer-to-peer. So I can sign certain certification, certain credential of my friend. I can say that my friend is very trustworthy. He worked very hard and is a very good engineer. And write that information, and then I can sign. And my friends have some verifiable credential by me. And another important model in the sovereign identity is a pairwise trust. In the blockchain revolution, I talk about all the identity information is controlled and managed by the website. So I proved myself to the website when I registered for the certain website, but do I get any confirmation or proof from the website that their website is correct one? So in the self-sovereign identity, since each person can have a control of the information, so when I first registered to the certain website, I can generate my proof, or I can sign the information to the website. And when I log in next time, that website have to prove that, have to have a certain credential that I signed by me to prove that this is the website that I first registered. So I can have a pairwise trust. So what can be achieved here is that we can prevent the phishing attacks. One of the reasons why there is a phishing attack is that the proof is only one way. User verify its information to the website, but website never verify their identity to the user. So if the hacker makes the same look and feel, and user ends up sending information, logging into that fake website, that's a phishing attack. But if you have this self-sovereign identity, we can avoid those kind of problems. And also, since there is a pairwise trust, we don't really need ID password system anymore. The site do not need to store our identification information, and we can achieve single sign-on system for all the government website using this pairwise trust model. So DID is related to the identification information. So since it's controlling the very important identification information, we need to have a very good privacy. There are a lot of regulations related to this private information. So since the identity information is stored in the control by the wallet, and wallet is normally application that is built inside the smartphone. So smartphone can have a fingerprint or iris or face recognition feature. So we can solve the problem of last mile identification problem. So we have a digital certificate, but there should be a certain missing link between this identification information and actual person. So we can minimize this gap utilizing artificial intelligence and smartphones. So most of the self-sovereign identification model is based on the smartphone and mobile environment. So we can think about this scenario when when website is identifying the user, they use the smartphone to look at the face, and we can recognize whether this person is a real person. We can match this identification information with the information that is on the server. in the worldwide, there are many cases in the digital ID. So one of the represented one is India's Aadhaar project. They put face recognition information and fingerprint and then iris. They keep all the information in there. So this can be a single identification, universal identification nationwide. So if you have this kind of identification, what can be done? We can have an easy contact tracing and vaccination. So in the COVID-19 scenario, we want to, we don't have any vaccine yet, but if there is a vaccine, because vaccine costs a lot of money, we cannot vaccinate everybody, then how can you efficiently vaccinate people? So what you can do is that combining the contact tracing and the vaccination facility, so that if the person is went to the market that has a COVID problem, then we can check everyone there, and then we vaccinate all the person or the family members of the dangerous person. Then we can reduce the cost to the vaccination and make it vaccine more efficiently. And I think this is much more important, immunity passport. So because of the COVID-19, every nation has a large economic problems. It cannot work. So if there's a dangerous, we can let nobody work. It's not a good idea. So what it can do is that we can have immunity passport. If you combine with the vaccination and then contact tracing, we can give someone certificate that this person is safe. So this person can travel to, ride the airplane and travel to overseas, or can work to the company. So if you have a large number of people in the factory, how we can allow someone to enter? So if you have this kind of immunity passport, it will be very easier and cost-effective way to do it. And we can implement contactless banking. So currently, we have to provide some identification information. Still, there are a lot of anti-fraud technology involved in it, but digital identification is far more advanced. We cannot still guarantee that this person is a real person. We just have to look at the picture, and then picture doesn't look the same, then we have no way to know it. But in the digital identification, we can have a face recognition and all the certificate. And also we can check in the real time that this person's passport and some ID is valid or invalid in real time. So in creating the account, we can have a fully paperless, contactless banking account creation. We can have a mobile banking with this self-sovereign identity. So let's talk about the digital money. So we already have a digital money.
Yeah, I just did something.
Okay.
Mr. Yun, very rich source of information, and with a lot of technical terms, I think. So just wanted to point out my question to the viewers. Are there any questions they might have so far? And so before we move on to the next chapter, I'll ask the viewers if you have any questions on the how blockchain operate, consist of, how tokenization operate. Would be great to have any of your thoughts kind of addressed before we move on to this digital money. Yes, please. Yes. Someone seems to have a question.
Okay.
I'll just.
Hello, sir.
Hello.
Can you hear
Welcome.
me?
Yes.
Hi. Yeah, I just have this question. It's kind of a general question related to the blockchain. I'm
Okay.
not an expert in blockchain, but I know there is an issue related to the speed of processing the transactions that relates to the proof of work and this process of proofing. And so is the application of blockchain really practical at this point? I think there are currently there are efforts to solve this problem, but scalability, this scale issue. I mean, compared to Visa and MasterCard, for example, the number of transactions processed is very limited. So do you think this problem will be solved in the future?
Yeah, I mean, this major question that everybody want to talk about nowadays. And the fundamental reason why there is a transaction speed, I mean, performance issue is that instead of having single entity in the other credit card and those systems, a single system that decide what to do. But in the blockchain, it's a decentralized, distributed system. Data should be distributed. And for example, if there is a transaction, this data should be delivered to everyone in the node. And everyone had to store those information, and they have to decide which one is right or wrong. So a lot more complicated process. So there's one of the reasons why they do this is that to avoid a single point of failure, that means increase the security. But the problem is they have to sacrifice the scalability. So this is a trilemma that everybody wants to solve it. So there are many technological proposals to solve this one. Maybe they have a state channel instead of doing every transaction or every operation by this distributed way. They can have a single sender and receiver can communicate and do all the detailed transactions by themselves, and only the end result can be recorded in the blockchain, since blockchain is very slow. And same idea goes to the Ethereum Plasma proposal. Instead of everything on the main blockchain, they can have a certain virtual blockchain or layered blockchain on top of main blockchain, and many detailed things can be processed in the blockchain, and then only the important result can be recorded on the main blockchain. So there are many ideas coming out, but fundamentally, I think that's the problem. And in my opinion, we need to solve the scalability in the three different point of view. One point is that, so I say the communication, computation, and the content. Content is the data. I talked about this is event sourcing database. We record all the historical information of tokens. So whether this token is generated about 10 years ago, and that token transferred to someone, that token transferred to someone, and so maybe among 1,000 transactions, that token eventually come to me. So instead of storing that I have a 1 Bitcoin, I have to, the blockchain have to store all this historical information. This is not really scalable at all. So we need to solve the problem of this data scalability. The Bitcoin, the node blockchain information is having about 200 gigabyte, and Ethereum is more than trillion. So there's a known secret that no single node has a full information. They can just only store the fraction of the information. They cannot store all the transaction information from the beginning. So this kind of data scalability problem have to be solved. And the computation I just briefly mentioned, then if you have a smart contract, we run the program, just sending the transaction information is also with overwhelmed. There are too much information for just a single transaction information, but if you run the program on top of it, and then we record all the execution information on the blockchain, that's actually nonsense. We cannot really have a scalable system using a smart contract. So this is actually the design flaw. So we have to fundamentally redesign the blockchain system. So some people believe in some gradual improvements. They can improve one protocol at a time. But in my opinion, we need to redesign from the beginning. So that's why we are working on concept called rewriting Satoshi. So we have to go back to the fundamental design criteria before Bitcoin. What is the fundamental meaning of blockchain, consensus, and everything? And so we have to come up with the new design criteria, how to do. And we have to design the new blockchain system from the ground up. So this one of the actually project we are working on with the University of Southern California. Professor Bosca is one of the leading blockchain experts in US, and we are developing technology called the meta blockchain. So we'd like to aim on designing a new system. So there are some blockchain protocols that solve one or two things, like Algorand and some Dfinity, and many projects, they are solving one or two protocol and had a hash graph. Many good ideas, but I don't think there are blockchain technology that solve everything yet. In the point of view of communication, computation, and contents. So we have to have a data scalability, and we have to have we have to run the smart contract in a national level. So millions of people, billions of people can independently run smart contract. Otherwise, we cannot have a programmable money. So basically, the conclusion is a little bit difficult to see, but so far, I don't see any promising technology yet. And I can say that I'm still working on it. So we don't know whether there will be massive deployment of blockchain technology. And we're gonna talk about this CBDC, but the problem is that CBDC should be used by all the people in the nation. And this is a massively scalable system. So if you do not solve this problem, and the CBDC may not work, or other promise of this digital utopia may work. If you think about Internet of Things, and then the scalability issue goes more massive scale up.
Okay, thank you for the answer. But I think there's some other optimistic things on the horizon, right? Because the overall processing power of the network, the computer processing power of the network is increasing over time. So that could be one of the factors, right?
Yeah, that's one of the factors, but that's only the computation issue. There are also communication and data issue. So each node, for example, in the Ethereum, each node full node have to store 1 terabyte. So this system cannot run on a mobile device. It's impossible. And the communication issue, if you have to broadcast every information to the older people or even the worldwide people, how can you make this system scalable? The computation is one issue, but we have a communication and data, other issues. So if you can come up with a new protocol or new mechanism that can solve the problem of these 3 things, then you'll be the hero of next Satoshi Nakamoto.
Okay. Thank you very much, sir.
Yeah. Thank you very much for your.
We have one more question from our viewers, and that is probably applies to everyone. Asking, would you mind, sir, to share your presentation slide with us, and would you let us to use some of the content of it in our future education works and projects?
Yes, this is open source. I don't have any confidential information here.
Right. Yeah. So no more questions, so we can move on to the next section. Thank you.
Okay. Thank you. Thank you very much. And let's talk about the digital money. And we actually already have a digital money. The credit card is a representative digital money. The money is already digitalized. And now everybody knows about cryptocurrency. This is also one form of digital money. And now many people are talking about CBDC is another form of digital money. So there are many different aspects. Make it simple, I summarize these 3 representative characteristics. So in the credit card, we have it's an asset-backed. We have to have a bank balance, otherwise we cannot spend money. And this is account-based, based on the user's account, and also have an identity-based. The bank have to have a KYC and anti-money laundering. All this identification related management is done by the bank. And cryptocurrency is very opposite to this. There is no asset that backing up the token. And it is tokenized. This is a new technology, but anyway, and it's anonymous. Many people say this is pseudonymous, but basically it is anonymous technology. No identification information is involved. And CBDC, there are still debate whether we're gonna have a account-based or tokenized. But I think that the real meaning of central bank digital currency, especially digital cash, is a tokenized one. And it should be asset-backed. We cannot generate the token out of nowhere. And it should be identity-based. So there are many technologies involved, and David Birch, a very famous writer about, he write about identity is the new money. And I like his book. And I shared, he shared his thought about the categorization of digital money in the Twitter, and this is a current version. And we can have a account-based electronic money and then electronic cash. So cash is could be token-based, but it's not really token-based sometimes. So we have a multiple categorization, but if you look at in the right bottom corner, we go to the decentralized or not. So basically Fed coin, central bank digital currency, and the cryptocurrency. Major difference is whether it's centralized or decentralized. When you're designing the central bank digital currency, people prefer to have a compatible model. So since we cannot ignore or eliminate current banking system, first approach is that emulate the current banking model and change it to digital. So they come up with a two-tier model. Central bank generate the token, and the other commercial bank, they request for the digital token based on the, this is the same model as base currency, the M1 and M2 model. So central bank is the ultimate authority to generate the CBDC, and then commercial bank request the CBDC and then use it for lending and anything else. But in my opinion, the real meaning of central bank digital currency is a tokenized model. In here, we can directly deposit token to the every single individual in the nation. So I can say that this is an easy quantitative easing. So many of the problem in the current model is that money didn't go to the people who actually need. It just, even though we have a lot of quantitative easing, but most of the money, more than 90% of money is just circulating inside the financial world. But if you have this kind of central bank digital currency, now we have a way to directly give money to everyone in the nation. And this comes with a talk about base income model. Whether we can give the money to everyone in the nation or not is a political issue, but technically, currently it's a little bit difficult. If we want to write a check to everyone or send the paper money to everyone, it's very difficult. But if you have this tokenized central bank digital currency, we can virtually give everyone maybe 1 million soon per month out of thin air. We can just like a magic genie and then send the money to everyone. That's very easy. So we can implement basic income but with very little cost. And also we can have a time bomb. So to accelerate, to boost the economy, if the money is just, the velocity is also the problem. If we give the money to the people and then people just put this money in the house and never use it, then economy will never be boosted. But if you can put some programmable money feature and then it can disappear after 1 month, or even you can say after 1 week, then people will spend money within the time period. Otherwise, the money will be disappeared. So something unthinkable from the paper money world with the central bank digital currency, we can do the kind of new version of monetary policy. Why? In the world of central bank digital currency, Sweden is one of the leading countries because already they're almost cashless society. If you go to Sweden and try to find some cash to use it, it's very difficult. And they want to have an e-krona. So there are many benefits of a cashless society. And because of the COVID-19, and many people know that this maintaining the currency, paper currency is way too costly, especially if you want to redominate, change the currency and then redenomination costs, generating new money, and it costs a lot. But if you have this digital currency, the cost goes almost zero. I mean, not zero, but very fraction of the cost. You can maintain it and generate the money. But in my opinion, more important factor is that there is a global currency war. So many people talking about digital dollar in the US. So digital dollar is the tokenized or digitalized dollar you can think about. In the paper world, there is some limit or time gap when Federal Reserve generate the money and then the money go to spread worldwide. It takes time. But if it's a digital, it can be spread worldwide almost instant speed. And what will happen is that you're gonna threaten local national currency. So in this currency war, one of the ways to survive this is we have to have a better currency than digital dollar, more usable, better currency. And not only that, there is Facebook and other large corporation. They're talking about a stable token based on dollar or major global currencies. They can also compete with the local currency. So instead of just holding on to old model, it could be maybe national political issue to develop the digital currency, central bank digital currency, to compete with this future currency war. So in conclusion, if you have a digital money, this kind of model can happen. Let's say we have a autonomous vehicle, self-driving taxi company. This taxi company is virtual companies, decentralized autonomous company, and digital company. And then let's say everyone has a basic income. Using the basic income, they can invest to this company with a tokenized stock, tokenized shares. And the self-driving taxi is driving around, and the user will pay this tax with, of course, digital currencies with the CBDC. And there's an electronic smart grid on the road, and they have a tokenized payment because charging just stop at the stoplight and then charging few dollars, very small amount of money. You can pay tokenized. So if you stop in the traffic light and then charge a little bit, and then next traffic light charge a little bit, so we can pay token by token, something like that. So from the digital utopian country to enable those kind of country, we need identification information, digital identity technology, and also this digital money, tokenized digital money technology is the key to realize the dream of this digital utopia. And to become a nation and the society that is have a competitive advantage over in the next digital revolution. So this is my brief talk about digital money and digital identity. Thank you very much. And any other further questions?
Thank you so much, Mr. Yoon. It was indeed very visually informative session. I'm sure all our viewers have got a lot of value in it. So now, if we just devote some time for general questions or anything related to any slides we covered. Dear viewers, please, either you can raise your hands or you can just type in your questions. And I will pass on to Mr. Yoon. Yes, we have a couple of questions. Please go ahead.
Hello, Mr. Yoon.
Hello, nice to meet you.
My name is Davron. I'm a Deputy Director of National Agency for Project Management. Our agency is responsible for blockchain issues and cryptocurrency in Uzbekistan. And this topic is very, very interesting to us. We are going to broaden the blockchain system technology in Uzbekistan. Also, we have now this year we start discussion with our central bank to issue our electronic money. But we have some big questions from partners. So they, this is a new technology. It's a very new system. It's coming the new financial system connected to the new technology, and so traditionally central bank is a very how to say they work very traditionally. They want to know everything. So if we will issue the electronic money based on the blockchain, how it will be with the accounting, how it will work with the IML standards. So you know that there are the international standards issued by the FATF, etc. So
yeah.
when and we shouldn't make some problems with these issues. And my question is how it's going on globally with these questions, with the IML, with financing of terrorism, IML, etc., with accounting as well. So just imagine that some of the companies going to become start work with the electronic money. So they start producing the goods, and they selling the goods for the electronic money, and how they should do with their accounting, taxation.
Yeah, very good questions. Yeah.
Thank you very much.
Yeah, very good questions. So this is actually the debate that I do with the Dave Birch on the Twitter. That because I talked about blockchain and current technologies anonymous, pseudonymous space. So identification information is not related. So if you think about this system, if you adapt the cryptocurrency technology to CBDC, we have this anonymity problem. So we cannot satisfy any kind of regulations. And also we have a private blockchain that can control everything. But the problem is that we cannot have a nationwide scalability. So we can, in Korea, we have some model like local currency. So within a certain city or a certain district, we publish the money and you can use it locally. But CBDC is the global scale. So even though we generate the CBDC in one nation, if we can only be used inside the nation, that's okay, but it's not really a desirable feature. So if you want to achieve the global scale and also have to meet the regulatory purpose, one of the keys is that we have to solve the identification problem. So that's the reason why if you look at my patent, I write about many of the patent-related identification and the blockchain. So how we combine this identification information. And for example, when I'm building the exchange, we are the only one who has who satisfy the travel rule of FATF. So that the token information and the identity information have to be transferred at the same time. So one way to do it is that we have an identity blockchain and then the token blockchain combined. So we have to solve this kind of problem first. And another problem that we need to solve is the scalability. And if you think about some of the blockchain companies that are working on identity, they are having a hybrid approach. So it's a public, but private. So what that means is that some of the entity in there is a private, have to have a permissioned entity, the identified entity, but there also is a public so that it can be scalable. Anybody can enter, but on a permission. So this kind of a hybrid approach is important. So basically, similar talk with other blockchain current scalability problem. So I have looked at that current blockchain technology, and then there is no really good technology, including Hyperledger and Coda or those private blockchain or enterprise Ethereum, or those kind of project has a kind of design flaw, design problem, so that this is not really a good fit to building CBDC. So I'm kind of working on designing a new system that is based on the identity, and it should be able to globally scale.
Okay, thank you very much. I hope that these issues will be on the agenda, and mutually we will find the solutions how to go on this issue. I know that this crypto is identification is number one issue. So I mean how to combine the traditional financial system with the cryptocurrency.
Yeah, so we are almost on writing some basic papers, finalizing it, and maybe within 1 or 2 years, I can show you some of the results.
Thank you very much. Good luck in your work.
Yeah, thank you very much.
I would like to also ask, and there would be something to complement to this question, is that as I see, as you mentioned from your initial slides, that you currently operate around venture sovereign wallet network, which has a presence in Uzbekistan as well. So, so I assume like before starting up with this venture, obviously you must have had a very detailed research of the market and things. And obviously with this blockchain technologies, I mean, the opportunity is kind of limitless. But you also mentioned some of the cases, examples in your slides today, but and most of them, they require quite a number of resources, a very certain amount of time frame involved, and a lot of buy-in from both governments and the organizations. So, so my question is that from your research and experience of in Uzbekistan and also in this particular field in recent years, what are the use cases of blockchain-powered transactions and exchanges would you see that can be relatively easier implemented in our country, and given the current infrastructure which is already in place? So something which can be done today or in the next 2-3 years maximum, that would somehow can be used as a way of introducing this to both businesses and governments and also end users, see the actual benefits of it, and then use their own imagination to kind of build up from that.
Yeah, I'd like to first mention the innovator's dilemma. So any kind of new technology deployment, there are some rejection or objection from the current stakeholders. So, for example, in Korea, one of the successful story of internet broadband deployment is that in US, it was not successful because there is a very strong cable network companies. They don't want a competing new infrastructure. But in Korea, we don't have any strong cable network or good other communication network at that time. So we can easily deploy the new high-speed broadband internet and become a digital nation. So like this banking and digital banking and electronic commerce and digital identity, if you have a strong infrastructure or strong company or the other stakeholders' interest, it's very difficult. But in my opinion, that Uzbekistan has a very good opportunity in this regard. We are a little bit behind, but because we are a little bit behind, there is also very good opportunity. Then we can deploy this most advanced services and then concept without any kind of some restrictions or objections or some social debate or things like that. So we can easily deploy it. And to do that, we have to think about the future scenarios. What will be the most beneficial to this country? What kind of technology, what kind of utopian society we want to dream of? And based on the concept, we have to think about the action items, which one to develop and which one to deploy, and then roadmap, and those kind of research should be done. But love image is that instead of approaching through digital currency or financial blockchain system, it's easier to approach through identity blockchain, because there are many, much more application to do that in the identity blockchain. We can digitalize university, like university certificate can be digitalized, or some kind of vaccination or COVID related things we can digitalize, or we can eliminate some of the paperwork, since it's very difficult to have a physical contact-based service in the COVID-19 period. And one of the reasons why I think this is a good strategy is that, in my opinion, having a very good identity infrastructure is a precondition to have a very advanced CBDC or financial service. Because many of the blockchain technology, just like I mentioned, is that lack of identity mechanism. So we have to advance further to internal value, to Internet of Identity. So we have to build up identity protocol and identity infrastructure to deploy CBDC. So any nation or any society who can be in the ahead of identity blockchain and identity system can be ahead of digital currency also. So that's my opinion.
Thank you. That's very insightful. And it's very important to kind of learn about the different perspectives for someone who is like not living in the country, but actually can see things from a different angle. So,
right.
Very useful. Do we have any other questions? Let me see if I have any text messages here. Well, seems like we haven't got questions left, but I'm sure. Oh, there is something just came up. Would you like to tell a few things about the use of tokens in voting process of public companies? That's the question we just got.
Yeah, I mean, if we use the blockchain, how voting will work in the blockchain is that, for example, we can generate a voting token. If we have a shareholder, we can generate a voting token to, maybe there's 100 shareholder and 100 voting token. We generate it, they can use it to vote with executive selection, and it can be anonymous, but identified. Only the person who received this voting token can vote, either to A person or B person. But the 100% who actually vote can be hidden, can be anonymous. But because of the blockchain technology, originally there is 100 voting token. So if you receive 100 voting tokens somehow, the perfect voting is possible. So in reality, basically, user can hold a wallet, and then they can create the voting. So.
That's awesome. So yeah, that was helpful. So if we haven't actually asked if you have those extra time availability, because we seem to have a little exceeded the schedule timing of the webinar.
Yeah,
but,
I think I have a 5 o'clock, so about 10 minutes.
Oh, okay. Yeah, that's great. That's great. It's just, I think it kind of, it requires some time to kind of digest all this big flow of technical, mostly information, and kind of make up and refine the question. So I think that's the reason that we have some kind of delays. But I think from questions, we can see that the other viewers really kind of got the really very well kind of received the kind of content, and they're very much kind of engaged in it. So I think we already have, wow. So that's what's just been justified. So we have questions then. What about regulation issues? Also about derivatives on cryptocurrencies, and also what about X rate of cryptocurrencies? So if I can combine all these three in one.
Yeah, I mean, legal issues is, I mean, people listening to this talk may be more expert than me. We need to, I mean, for example, if you're gonna enable DAO, then we have lots of rigor effort to be done. So whether we can allow this virtual company to be the company, and then whether we can allow people to invest in the token, and the token can be considered as a stock or something like that, and the digital stock, and what will be the accounting regulations for that, and all this kind of regulation required, and whether we're going to allow any kind of company that there is no human, only the robots exist, and something like that, whether they can be still be the company, or how kind of rules that whether to give the basic income that can be used for the investment, or like there can be some portion, only the 50% of all the basic income that they have to use for the food or living, and then they can only invest less than 50% of their or the income or something. There are many rules to be made and then established. So many of the regulators, many think about protecting the current infrastructure or current industry, especially protecting the financial industry. But if you are, try to advance, my view about regulation is meant to create the wealth, that create the, it's a little bit difficult. I mean, so if you try to create a new world and try to be happy and try to be more advantage, the regulation should focus on creating a rule to realize this dream instead of protecting something. So before regulation, we need to think about what our goal is. What will be the best interest of the nation, best interest of people living in here, so that whether we should realize this or just protect current industry and stay as a current system. So before think about regulation, we have to think about the intention. So in the future, one of the key issues is that smart contract is one of the think about new way to have a law-based society. So my opinion is the law is a dispute resolution mechanism. In the normal case, we can live happily and do the business and as our interactions. But if there is some problem, we can go to the court and then do the dispute resolution to solve the problem. But the smart contract and this kind of new law way of doing is that instead of having this slow and costly dispute resolution, why don't you have some smart contract, the law or agreement front end before we do anything, so that those kind of resolution can be solved automatically. So if you deploy or build a regulatory structure to enable certain new action, we can avoid many kind of inefficiencies. So in the new world of blockchain, we have to think about what is the fundamental role of regulation and the law. And if you can agree on that this law and regulation can serve as creating a utopia, brand new services, then we have to move that direction to create the law regulations.
So just checking out if there are any other questions so far.
So maybe one last question.
Yes, yes. Well, I think we already covered all the questions,
yeah.
I think. So I think we are in a good position to conclude our session now. And so in this regard, I would really love to thank you for your devoted time and sharing all this expertise and experience and knowledge with us. I'm sure this was the first interaction with you, and as the head of international cooperation and industry partnerships, we would love to stay in touch and follow up with you in the coming days and months, trying to explore what other interaction points we can build up together on a more advanced and different level. So we'd be happy to be involved in that. And so thank you so much. We really appreciate it. And this particular subject was also very relevant to our school's programs portfolio, because just before this pandemic outbreak, we had not one, but two blockchain and fintech related projects internationally with our UK partners and also with our partners in Malaysia, which we had to reschedule, but we are working on it and trying to find the best possible date, both in this global digital banking in the global financial industry. So I think in this regard, this is very relevant and actual. So we would love to kind of continue in this particular direction as well, and try to deliver with even more insightful and courses in the coming weeks and months ahead. So thanks again so much, Mr. Yoon, for your time and for your presentation. As mentioned before, I will share your slides in our group, and if anyone had some questions, or maybe because of some technical issues we're not able to ask, feel free to forward those to me, and I hope you don't mind if there are some questions kind of came up that I can pass on to you. So thank you so much, and we look forward to see you again someday.
Yes, thank you very much. I really enjoyed it, and if you have any questions, always welcome. And thank you very much.
Thank you. Enjoy the rest of your day. Thank you.
Thank you.
And stay safe and healthy.
You too, everyone.
Thanks. Bye now. Bye, everyone. Thank you for your time, for joining us, and hope to see you soon in our next webinar sessions. Follow up our page on LinkedIn and on our Telegram pages. Thank you.
Thank you.
Bye.